In the previous lesson, we talked about the energy stored in deformed material. It's called strain energy or elastic potential energy. So now we go into a little bit more detail. So particularly for the case when the material is stretched over the elastic limit and start to perform the plastic deformation. Okay, so let's look at this graph here. As you extend, let's say in an experiment, you extend this material up to this point here. Okay, and we want to find work done in stretching the wire. It's very simple. That is the area under the graph within this point. Okay, it's the shaded area on the screen. That's called the work done in stretching the wire. So as you remove the force at this point, and assuming that it has already over the elastic limit, therefore, as I mentioned earlier in the previous lesson, it should go back through a line that is parallel with the Hooke's law line. So why does it go back? Again, we know that it stores some energy and it recover this amount of energy. Why do I say recover? Is because it will not be able to make full use of the amount of work done that has been done on it. It will just do work on its own with the, that is equivalent to the area cover under the new line plotted. There's the shaded region on the screen here. Okay, so that's the energy recover. Okay, so this energy recover, we can also use the term strain energy or elastic potential energy. So this is also called strain energy or elastic potential energy. Okay, notice that's the difference here. Compared to if it is extend within the elastic limit, it is not the whole area represented below the line anymore. It is just portion of it, large portion of it probably, and depends on how far you stretch it. So there are some energy that is not going to be recovered, and we call that amount the energy loss. So that's covered by these shades of red color. This is called the energy loss. Okay, so let's look at the particular case, and this is a bit special because it's for rubber. Okay, for rubber it behaves slightly differently, not like the metal. After you stop at the elastic limit and then you remove, so let's say you try to extend the rubber and then you try to remove, so what happened is that it will bounce back, right, very quickly. If you have a let me show you a rubber band first. Okay, so we have an example of a rubber band here. Okay, so let's say I stretch it and then that's loading, right? So at a certain point then I release. Okay, be careful not to hit your hand. You can have a rubber band get ready with you. Okay, we'll do something. So in front of you, then after that you just let go. So if you try to use a ruler to measure its original length and the one after it retracts just now, it's going to be the same, because that's how rubber band behave. Okay, or this kind of elastic band behavior. Okay, so what happened if it is after elastic limit? Nothing will happen, it will just snap. Okay, it is also its breaking point if you tear too long until it go over the elastic limit. There's no plastic deformation for rubber. Okay, it will just snap afterwards. You can try, be careful. Okay, so if you look at the graph, right, the unloading part actually does not follow the loading line. Okay, it's slightly lower, but yet it go back to the original point. That's why I say this is a special case. So when that happens, means that the elastic potential energy store is different. It is just area under this unloading graph, and then which means that there will be energy loss, which is covered by this region here that is shaded. Okay, which is called it has a special name, which is called the hysteresis loop. It's heat. It's going to be heat. Okay, energy loss as heat. So we can actually prove this. Very simple. Get ready with the rubber band here, and then you stretch a few times. Just stretch it. After that, you put it on your lips. It's going to be slightly hot, so you can try that. Don't worry, it's not very hot. Okay, let's try that. And then you put a few times. If you feel the heat, that means that it is true that this energy is lost at the heat. Okay, so if you do it in an aircon room or when weather is cold, then it will be easier to detect that. Okay, safety first, yeah. All right, let's look at the last exercise here. This exercise, instead of multiple choice, I want to make it into a group discussion. Okay, so I don't want the question here. So I want in your group, you can find that in the group on the Google link given, yeah, later. So if we have A, B, C, D here, I want you to highlight what is A, B, C, and D represented by the shaded area. You can shade that, you can draw a different picture, and then from here you say that okay, A is this part, and then the other one you say that okay, B is the whole thing under the graph here. Okay, I mean you draw it properly lah, huh? So and then you explain. Okay, if there's any clarification that you want to put in, you explain. All right, so or you can you probably find out that okay, this actually doesn't make sense. It is not represented. It cannot be represented on the graph because of some wrong wording, or it's a wrong sentence. Okay, so go through A, B, C, D and draw the graph beside it. Okay, and then you can put in some explanation. So we'll make it a forum discussion afterwards. Okay, so do find your group member, yeah. Okay.